Hello viewers, welcome to the another episode of Saksham based process control series. In the previous module, we controlled temperature, additive flow and pump operation. Now we reach at the final stage before packaging. Ensure product safety and tracking production. Only properly pasteurized juice should be sent to the packaging unit. If the temperature drops below the safe limit, the juice must be diverted back to the tank. At the same time, we also need to record how much product is being sent to the packaging throughout the day. To achieve this, we will use Saksham MOV block and Totalizer block. Let's implement the safety logic. First, add an MOV block. Drag a box from the toolbox, click on 3 dots, then navigate to Advanced Lib, Advanced and MOV on. Click OK. Rename the block appropriately and enter the initialization details such as tag name and description. Now connect the required input of the MOV block. Connect IO-ZSO to the corresponding open feedback signal of rack 1. Connect IO-ZSO to the closed feedback signal. Connect IO run FP and IO trip FP to the respective variable from the rack 1. Next, we will implement the interlock condition. The requirement is if temperature less than 72 degree, the valve should automatically close. To achieve this, drag an input and assign TIC101.DAC.PV low alarm. This signal comes from the temperature PID block and represent the low temperature alarm condition. Now connect this signal to the MOV control. Connect it directly to auto close CMD. Connect it to the auto open CMD without negation. Next, connect the cycle time. Finally, connect an output. Drag a output box from the toolbox and connect it to IO open command and connect it to the variable MOV_open CMD from rack 1. Similarly, connect an output block from IO close command and connect it to the variable MOV close command of rack 1. Once done, remove unused pins and arrange the block neatly for better readability. Now let's configure the totalizer. Drag a box and select the totalizer block from Advanced Library, Basic, then Totalizer and click OK. Rename the block and enter the initialization values such as tag name, description and unit of measurement. Now connect the input. Connect total underscore into the MOV IZSO. This ensures the totalizer only count when the valve is open. Connect PV to the flow signal. Drag an input and assign FIC102.in1.PV. Connect cycle time to the fast loop cycle time. Finally, remove unused pins for a clean structure. Now click generate code and connect to the device. Run the program. Now let's move to the SCADA visualization. From the visualization toolbox, search BL_MOV and select BL_MOV3W. Place it at the 3-way wall location. Connect the reference to MOV102. Similarly, add an totalizer display near the flow sensor. Connect it to the flow total to show cumulative production. Now generate the code, connect to the device and download the program. Let's test the system. First, configure the temperature condition. Click on TIC101, go to Advanced tab and in the Alarm Low section, set the value 71 and enable the checkbox. Since the current temperature is around 70 degree, the low alarm becomes active. Now start the process. Motor faceplate and start the motor. Set the required flow value. At this stage, since the temperature is below the limit, the valve remains in diverted position. Now increase the temperature. Once the temperature rises above the threshold, the alarm clears. Go to the MOV faceplate and switch it to the auto mode. As soon as auto mode is enabled, the valve opens towards the packaging line and the totalizer begins accumulating the flow. Finally, let's verify the interlock logic. Reduce the temperature set point. As soon as the temperature drop below the limit, the valve automatically close and divert the flow back to the tank. At this point, the totalizer stop increasing since no product is being sent to the packaging. This confirms that both safety interlock logic and accurate production tracking are working correctly. In this module, we learned how to implement safety interlock using temperature condition, control a three-way MOV valve automatically. With this, we have completed the core process control sequence from heating and mixing to the flow control, safety and production tracking. In the next phase, we can explore advanced features like alarm, data logging and reporting. See you in the next episode of Saksham based process control series.